All right, welcome. We're on Power Focus Area 2, the Conservation of Energy, and we're going to combine objectives 2 and 3 because they're both talking about kind of how to solve different types of problems with conservation of energy. They go really well together, and they're both pretty short, so we'll knock them both out here quickly. Start class like always with our daily quote. Today, some people dream of success while others wake up and work hard at it. And I love this quote because really, it's the work that gets you to your goals and your success. You can dream of being fill in the blank, a certain job, a certain amount of money, whatever. But if you don't work at making that happen, it's not magically going to happen. So to me, this quote's all about doing that work, putting it in. Remember, like always, when you're watching these videos, pay attention. They're pretty short. If you get sick of hearing me talk, press pause, walk away for a while, come back, and make sure you take some notes, but not too many. Probably a half page, 3/4 of a page is plenty. And in case you miss something super important in your notes, the last slide will always have the most important things from the video. Make sure those are in your notes. All right, so we're going to start with energy pie charts. But before we do, most of our charts that we do are going to include kinetic energy and potential energy. So I wanted to review those definitions, and this whole power focus area is about the law of conservation of energy, so I want to review that too. If you remember kinetic energy, all you have to remember is moving. It's the energy of motion. If something is moving, it has kinetic energy. Gravitational potential energy is, we call it the energy of height or position, but as long as you remember anything off of the ground has gravitational potential energy because it has the potential or the ability to fall. If we look at this picture of here, while she's holding the ball in the air, it's not moving, so it has no kinetic energy. But it could move, it could fall, so it has gravitational potential energy. And when she lets go of it, guess what? It starts to fall. We're going to come back to this picture when we review our law of conservation of energy definition at the bottom of the slide. It says energy can't be created or destroyed. It can only change forms. So we can't make energy, we can't get rid of it, we can just change forms. So let's look at what happens over here with the girl and the ball again in terms of the conservation of energy. We said here it's not moving, so we have all potential energy. But when she drops it, it is moving, so it's gaining kinetic energy. But the ball is going down and down, it's losing its height. So what's really happening is the potential energy is changing or turning into kinetic. Eventually, the ball will land on the ground. It's not in the air anymore, so it will only have kinetic. All of the potential energy will convert into or change into kinetic energy when the ball hits the ground. All right, now let's get into what we need to do in our checkpoints. Many of them for this project is how to make these things called energy pie charts. Before I even look at the picture, hopefully from math, you know pie charts are simply circles, and you might have certain percentages blocked off for one or the other thing, and they're going to be like that for this too, except we have to figure out what goes in each portion of it by making it all ourselves. So let's look at this picture here. It says at point A, right here before the ball is let go, so we're just holding it up here at point A, it's not moving. What kind of energy does it have? Press pause if you need to think of it. Hopefully you came up with the answer as gravitational potential energy. All right. Bullet point 2 says at point C, right before it hits the ground, what type of energy does it have? Well, it's not in the air anymore, and it's moving really fast right when it hits the ground, so it has kinetic energy. Of points A, B, or C, which point has the most energy? And go ahead, pause if you need to think of that. It's kind of a trick question. The law of conservation of energy says the total amount of energy stays the same. So what point has the most? All have the same. They all have the exact amount, same amount of energy. Now, none of that is a pie chart, but if we use what we just did, we can probably start to figure out how to make these. So what I always tell students to do, if you have to make an energy pie chart, first thing is just make a big circle for as many points as you're asked. In this case, A, B, and C are 3 points. All right. Starting at point A, we said the whole thing is gravitational potential energy. So all I do is write GPE, and that could be enough. A lot of students want to put the percentage and put 100%, but the pie chart itself would be enough because it shows the whole thing is GPE. Since we already answered C, I'm going to skip B for a second. At point C, it says it's all kinetic. So I just put kinetic energy, or KE, and that's it. Point B, though, that's tricky. It's still in the air, so it still has GPE, gravitational potential energy. But at that point, it's moving pretty fast, so it has kinetic energy as well. Well, guess what? If B is halfway between A and C, we just split our chart in half, put GPE on one side, KE on the other, and we've made our first energy pie chart. Not so bad. Figure out what kinds of energy are at each point and represent that in a pie chart just like you would in math. All right, I would like you to do the same thing here. Make an energy pie chart for point A, B, C, and D. And I would press pause if I were you, practice it on paper. I'm going to set it up for you. There's 4 points, A, B, C, and D. So my first step is always just make 4 circles. From there, figure out what kind of energy is present and how much. So go ahead, pause while you try this on your own. All right, let's see how you did. Point A, it's at the top of the biggest hill. Not moving, so it has GPE. So point A, all it has is gravitational potential energy. All right, now you can see this line here represents halfway. So this one is a little more than halfway down. So since it's more than halfway down, is it going to have more potential or kinetic? Should be kinetic. So as long as you have more kinetic energy than GPE, you're okay. If your line's a little off from mine, it's fine as long as the kinetic energy side is bigger. C, can it go any lower than here on this track? No. So it has no potential energy. It would be moving fast, so it's all kinetic energy at point C. And then point D, it's right on that halfway mark. So it's still in the air. And we said if it's in the air, it has GPE. And the energy can't go anywhere. It can't just disappear, so it must be kinetic energy the other half. Hopefully you got that right, but we'll practice plenty more before you see a content assessment, and even today when you go to the practice questions. All right, do the same here. Press pause now, and in a second I'll go over the answer with you. All right, let's set it up. A, B, C, D, and E. First step, just make a circle for each of your charts. And it's hard to write circles with a mouse, I'll tell you. These are really bad. But if I'm being truthful, I don't draw much better in person either. All right, now this is tricky. The person is throwing the ball up in the air. So for me, I just want to start, and you don't have to. If you started a different order and got it right, well, you're advanced, that's great. But I like to do it the easiest way, and always start with the highest point. So the highest point is always going to be all gravitational potential. And in this picture, that would be point C. So point C is GPE. The lowest point, it can't go any lower, has to be all kinetic energy. In this point, both A and E are at the lowest point, so they're all kinetic energy. And then we just have to figure out, where is this? If you think it's about halfway, which I do, I would just draw both points B and D half GPE and half kinetic energy. And we finished a 5 energy pie chart problem without much difficulty. All right, So what if we don't have to do a pie chart? What if we have to apply the law of conservation of energy using numbers? Well, this is super easy. For one, the numbers are never going to be tricky. Just make sure that we understand what's going on. And for two, the only thing we really have to remember is what I wrote up here as a nice hint. The total amount of energy always stays the same. Well, pick a spot, any spot. Well, I'm going to actually pick point A because they give us both types of energy. So if I add 20 gravitational potential energy joules and 0 kinetic energy, my total energy is 20. And up here we said the total will be the same everywhere. Well, if the total is 20 and 10 is GPE, how much kinetic energy? 10. 10 plus 10 would be 20. The total has to be 20. And right here we have 0. So the kinetic energy has to add up to 20 and is 20. Over here, the total's got to be 20. So if we have 10 of one, we have 10 of the other. And simple as that. The total stays the same everywhere. 20, 20. 0 and 20 is 20. 10 and 10 is 20. Total's the same, so we know we're right. All right, what about this problem? Same hint. Remember, the total amount of energy stays the same. So this looks like a crazy, hard, difficult problem, but it's not. It says a ball starts at the top of a ramp with 0 joules of kinetic energy and 100 joules of gravitational potential energy. We'll just add those up. What's the total? 100 and 0 is 100. If the ball at the bottom of the ramp has 0 joules of potential energy, how much kinetic does it have? There's no math. The total's the same. If there's 100 in one spot of one kind, there's 100 of the different kinds somewhere else. 100 and 100. Just remember that nice little hint, and these problems are super easy. This one tricks people a lot. The first time they see it, it tricks them. Not everyone, but it tricks a lot of students every year. It says at point A, the object has 20 joules of energy. So I'm going to write that up here. 20 joules of energy up here. How much does it have at B? Remember, just remember the hint. Total stays the same. So it has 20 at B. A lot of kids want to tell me 10. They're like, well, the GPE is lower, it's 10. You're right. If we drew this out, GPE is 10 here. But what is that GPE turned into? It's turned into kinetic, and we'd have 10 of that as well. So 10 plus 10 still gives us that 20. Guess how much energy is at point C? Total energy, 20. Guess how much is right here? 20. Right here, right here, right here. Everywhere I move the pen, it's always going to be 20 in this problem because the total stays the same. And probably the hardest problem, and it's not that hard, is one that's trying to confuse you. At point B, it says we have 5 joules kinetic energy and 10 joules of GPE, gravitational potential energy. How much kinetic energy is at point C? All right, we do have to think a little. First, what's our total energy? 5 plus 10 is 15 total. At the top, it starts with 15 because we must have 15, and it's not moving yet, so it's all gravitational potential. At the bottom, it's no longer in the air, so it's all kinetic, and since our total number stays the same everywhere, it's 15. Again, total always stays the same. All right, review. What should your notes include from today's slideshow? Definitely have the definition of kinetic energy and gravitational potential energy. Hugely important on our project on lots of assessment questions. Be able to explain that law of conservation of energy. Total energy stays the same. We can't make or destroy energy, but we can change its form. Have at least one energy pie chart practice problem and at least one practice conservation problem. So if you weren't writing those down, you were just doing them in your head, maybe rewind a little and copy one of them down so you have it and can reference it when you study. All right, since I did say we combined 2 different focus areas, there's 2 different QR codes to practice. You have these 2 at the bottom. Maybe you can't see where the pen is. These 2 here, the bottom 2, if you scan both of those, and I don't know why it kicked me out, but that's fine, it'll take you to your practice problems. Good luck.